books here in just a couple minutes, so get those settled. All right, question 14. As we're looking at 14 here, first thing I notice here is in this 14, guys, run away, please. Okay, 14. It's not obviously 45. It's not 30-60. It's just 47 degrees. We're using trig. So with that 47 there, standing at that angle. Okay, what's the 10 represent? Opposite adjacent hypotenuse. It is my opposite. And what's the, well, hypotenuse, I just said it. X is my hypotenuse. Based off of opposite and hypotenuse, you got to know your sine, cosine, or tangents. It is sine. So, again, that's something I will never give to you. You're on your own with that. So, next week, I will quiz you up at some point on that. Sine of the angle you're standing at is opposite over hypotenuse. Again, on that first quiz I gave you, that's going to be your first point. You get the equation correct. Second point is going to be, can you correctly solve for x? Getting in that calculator ready form. So, getting it solved for x. Now, we did a few of these already, and we saw there's a pattern out there. That x is going to become one of two things. X is going to be equal to multiplication, or it's going to be equal to division. And as we saw about for x, the x is in the denominator. And as we solve it for x here, we multiply both sides by x. The x gets kicked out of the denominator. All right, we got it over here on the left now. Still got to solve for x. How do we get rid of that sign of 47? We what? We divide. Now, I don't need to show this every single time. We saw this pattern happen where x is going to be equal to 10 divided by. So this is the next piece that I'm looking for on your quiz. Can you correctly get this in calculator ready form? 10 divided by. Now on your calculators today, this morning when I came into my and turn on my board here with the calculator, I always have to make sure, for myself, I got to turn it on. I got to turn on degree mode. You probably don't. Okay, yours should save from one day to the next. But I'm on degree mode. All right, 10 divided by sine of 47 degrees. Are you in the right mode? I am. That's where I'm getting at 13.7. So my guess is maybe Courtney, maybe did multiplication.
Yeah, I think I messed up.
Maybe you had x over 10. That could be my guess off that, which is very common on the first few times through. That's fine. No problem. You're good. Just you'll get plenty of practice these 2 days. Yeah, I got plenty of practice out for you. Okay. Watch that out. Okay. And then the other thing is to always make sure you do a quick check sometimes on the grade level. Good question there. We're gonna do more work on this all week. All right. Anything else anybody's got? If you did not turn your homework in the other day, just turn it today. Make sure your name's on it. Throw it in the basket. Let's get. Going to use everything we ever talked about? No, just not. Now, depending also where you guys go for your career, what your thoughts are for where you think you might go for maybe a job. I thought sitting in your guys' shoes, I was going to do engineering. That did not happen. Now, my first year and a half, I was a computer engineer. It wasn't what I wanted to do. I switched out, so it is what it is. Okay, so wherever you think you might be aiming for now, may not be the case. So you never know what's going to happen out. Now, with things, okay, if you are looking at something that right now might be around engineering, in terms of like architectural, construction, interior design, something along those type of lines, this is a good use of all the things that we've been talking about that are there, the social rights, the trig. These are good examples of where we can apply it. So on this page here, we're building a wheelchair ramp. Now we've all seen wheelchair ramps, right? How many of us have seen wheelchair ramp like that? What's the problem with that? It's like a wheelchair ramp. 2 feet, way too steep, right? A few things going on with that. One, if you try to wheelchair ramp up that, it's going to catch the feet of the wheelchair ramp, right? It's going to catch the feet, you're not going to be able to get up that. Second thing is once you do adjust yourself, try and push the wheelchair up that ramp. Not very easy. And then secondly, if it is a motorized wheelchair, you're going to have a hard time getting up that, right? And then even going down that, probably not safe either, is it? So, just fine, right? So obviously there's certain things that can happen. So let's say you end up building a ramp like that, you are on the job site, building that ramp, what then happens? Well, no, before that person even comes to the wheelchair, what's gonna happen? So you're on a job site building it, who comes around?
The manager.
You know? Well, man, for sure,
Supervisor.
we go higher.
A person in wheelchairs.
So you have inspectors. Okay? You have inspectors from the city, from the county, that have to come around and they check off certain parts for safety. So yes, you have your obviously job manager, your construction managers and all that. But, you know, if you do something like that, you know, we have codes out there for particular reasons. And that makes no sense, right? So those inspectors are gonna say, yeah, that's not gonna happen. You're gonna rip that whole thing out and start from scratch. You keep building things wrong, maybe not that type of steep level, but there are certain codes out there where you gotta make sure wheelchair ramps are not too steep, so that those type of things don't happen. You keep doing things wrong, what's gonna happen? Are you gonna keep working there? Probably not, because that loses money, right? So here on this problem, that's what we're talking about. There are certain codes out there, and one code here is based off the ADA Act, okay, the American Disabilities Act. Says, all right, for this wheelchair ramp, it says it must have a maximum incline for a safe wheelchair ramp should not exceed a ratio of 1 to 12. What does that mean? It means that for every 1 unit of vertical rise, requires 12 units of a horizontal run. Where have we talked about that before? Slope. That's our slope, isn't it? So all that math that we've talked about before, it is hiding behind the scenes in those types of areas. Okay? So you just can't go out there. Maybe at your house you might be able to do some of that type of stuff. But if you're doing this for a living, it's not going to happen. Right? Or you're not going to be working that job very long. You're not going to be very good at it. Okay? So in this instance here, we got to figure out. Okay, here we are. This is where we got the room for it. Okay, this particular place has the room to make this ramp off to the side. If you don't have the room for it, what you then end up seeing on some of these buildings, you've seen those like ramps that do that zigzag, and eventually you get to the top, right? It's because a lot of those ramps just don't have the room to make a long run like this one's doing. Okay, so they have a shorter place, but what they can then do that is start to increase that height by doing that zigzag ramp. And then they get to the top. All right. So here, this place has the room for it. Let's go build this ramp. Okay. As we build this ramp, something is absolutely set. We cannot change the height of the porch. Okay. So the porch height, that's what we're talking about right here, that rise is 2.5 feet. Like you can't change the door. The door's set. So we measure out from the ground to where that 2.5 is. That's set. So you slap down your joist. The joist is what the surface level of that ramp is going to land on. Okay? So your plywood's going to land on top of that. Are you going to cut those joists down to 10 feet? 15 feet? Is that going to work for you? You're going to have a ramp that meets the code, or are you going to have a ramp that's way too steep? So that's that 1 to 12 coming into play. All right? So let's figure that out. Let's go back to our last topic, our similar triangles. As Deacon said, that rise and run represents our slope. So we don't know our run. If we don't know something, what do we do? Yep. Well, that'd be a variable. We don't know what our run is. We do know our set height is 2.5 feet. Our rise is 2.5 feet. All right. So if we think of our rise and run, that has to be 1 to 12. That ratio has to be 1 to 12. What is our set? Our set rise, we know for sure. And where's that going to go? That's our rise, 2.5. Now we don't know what our run is. Our run is now determined off that 1:12 ratio. So where's that going to go? It's going on the bottom, right? That's our run. Done it all before, haven't we? There's our proportions. Cross products, right? Go with your calculator. 1 times x, well, that's easy. But 12 times 2.5, that's going to tell you what your run's going to be for that ramp. So when I cut those joists, it's not quite yet, but it gives me an idea then how far out I'm going to need to put that. And when you do 12 times 2.5, what is that? It is 30 feet. So this is a pretty long frickin' ramp in order to meet that requirement by the ADA. 2.5 feet doesn't sound that tall, does it? But in order to meet this requirement, so that it is a nice incline, I mean, think about it. If it's just one person having to wheel up by themselves, it's not a motorized ramp. You don't want a big incline, do you? That's pretty cruel. So you want to have something that has a very gradual incline. Therefore, that's where the 30 feet's coming into. Okay? So we have a 30-foot ramp. You're gathering your supply list. You now know you got to run at 30 feet. Let's figure out your surface level. Okay? Let's figure out the length of the surface level. That's really where some of your joists are going to be coming into play. So, what's my surface level? How are we going to determine that? I'd say this is not a 45, is it? This is not a 30-60, but we do have good old Pythagorean theorem, right? Set it up. 2.5 squared plus 30 squared equals, go at it. We've done it all before. Pythagorean theorem will never leave you. 45s will never leave us here. You'll use Pythagorean theorem in those areas. I know you'll use some 45s as well. You'll use some trig out there as well. Okay. Now, in this instance, you're working that out. 2.5 squared plus 30 squared. And what are you going to do with that number? You'll square root it, right? We've done that all before. You get a number. Let's round it to nearest tenth. Nearest tenth. 30.1, right? 30.1, which is pretty darn close to 30, right? And the reason why those are going to be very close, you've got a big number of 30 working with 2.5, which is pretty small. Because of 30 and 2.5, it does come out pretty darn close to that 30. Okay. Now, with that 30.1 as the length of that surface, then out on the job site, they're not going to care about 30.1. They're just going to say, yeah, I need something about 30 feet. Go a little bit past that, they're not going to care really about that in terms of ordering supplies. But from us, from the classroom standpoint, we're going to say, hey, it's going to be about 30.1 feet. Okay. All right. So from there, now I want us to calculate the angle. The angle that it forms, the ramp forms with the ground. Because this angle then keeps popping up over and over and over with the ADA, with this 1:12 ratio. So if you are working here in that job site, and your job is kind of specializing in those ramps, you're going to keep seeing these angles, this particular angle pop up quite a bit. How we define this angle, guys? So let's go stand at the angle Y. Go label it out for me. What's the 2.5? All right, I've got two sides up there, don't I? 30, and I just found the other one, right? 30.1. If you can avoid it, do not use the rounded side. What side do we round? Hypotenuse. If you use a rounded side, your next answer, that Y, is going to be off a little bit more. Okay? Hopefully that makes sense. So sometimes you have to, sometimes you can avoid it. But that 30, do we have to round on that 30? Go with those exacts. So opposite and adjacent is what I want to use. Sometimes you have to use a rounded side. You can't get away from it. But let's use that opposite and adjacent. Okay? What do we got? Sine, cosine, tangent. Alrighty, let's write off to the side. Tangent of the angle we're standing at, which is what over what? Cool. Just like we did a little bit on homework, that's what we've been doing last week. How we solve for the variable? Oh, it's the angle.
The negative.
All right, this is the inverse. So this week we're gonna get a little bit more practice with that. I don't expect you to be total masters yet. This is where we're finding the inverse. Everything has an inverse. The angle here we find by taking the inverse of tangent. We say arc tangent, or the inverse of tangent, it's tangent to the negative 1. So 2.5 over 30 then. Inverse tangent of 2.5 over 30. So what we're asking our calculator to do is say, hey, go into your trig library, go look at and find me a tangent, inverse tangent ratio, go find me an angle that has 2.5 over 30, opposite adjacent over 2.5 over 30, and then let's go look at its library. And yeah, 2.5 over 30, whoops, 2.5, isn't it? 2.5 over 30, and what did I just hear? Correct. So off of that 4.7, 4.8, 5 degrees, that's that angle that's going to happen out quite a bit with those angles for the ABA. All right, so we're going to go to nearest degree. With this in case is going to be about, how many, if I can write that better, how many degrees? Sorry, nearest degree. 5 degrees. When I say nearest degree is nearest whole number. So its side length is 10th, angles is nearest whole number, which is 5 degrees. Okay, so 5 degrees is about what that should be, nothing higher than that. So if you're just working at that job site, again, and you say, 2.5 is the height, I cut this down to 15 feet, what's that ramp going to look like? The ramp going to get what? It's going to get steeper. Yeah, if you say, screw that, I don't know what I'm doing, I cut that joist to 15 feet for a run, that's going to be a pretty darn steep ramp at that point. Okay, so those are the small things. What might seem small, that's how it impacts everybody's daily life. And behind the scenes, Deacon said slopes happening, we get our trig happening, we get Pythagorean theorem. All those small things are happening out there. Okay. All right, let's do a little bit more here. Let's introduce you to tangents, lesser known cousin. Okay. So tangent is what? Opposite over adjacent, right? We started talking about that last week. And today we're going to introduce you to, on the next page now, next page, tangents opposite adjacent. And the lesser known cousin, it's not as popular, is what we call the cotangent function. Now, the cotangent function, we're not going to do a ton with it, but it's going to happen out next year in Algebra 2, pre-calc, physics a little bit maybe. It also happens on the SAT as well, so we'll have to talk about it. Now, the thing I want you to remember today and take away from the cotangent function, cotangent, is this. The cotangent function is the reciprocal. It's the reciprocal to the tangent function. What do I mean by reciprocal? If I say 3/5, reciprocal is 5/3. Reciprocal is just the flip of it, right? So that's what I want you to take away from today, is that the cotangent is the reciprocal of tangent. There's no mnemonic device I'm giving you today. There's not a great mnemonic device, like I said, with SOHCAHTOA. In SOHCAHTOA, we can kind of remember tangent is opposite over adjacent. For cotangent, I'll throw out 2 new ones with you Wednesday, Thursday. There's no stellar mnemonic device that you're saying, okay, for those. But for cotangent, I want you to remember it's the reciprocal tangent. Now, what do I mean by the reciprocal tangent? Well, if tangent is opposite over adjacent, what's the reciprocal of that? Adjacent over opposite, right. I never remember it like that. That's just me. I always remember, hey, if I know what tangent is, tangent, then what's the reciprocal tangent? Adjacent over opposite. Just doesn't roll off the tongue as well. That's just how I've always done it. So let's do some practice with identifying or writing the cotangent ratio down here. Tell me the cotangent ratio of angle D. Okay? I want you to write me the cotangent ratio of angle D. So let's do that. Nothing crazy. You're not solving for like an angle or anything with the cotangent ratio. You're just writing me the ratio. Now myself, when I'm asked these, in my head, I'm always going first to what I'm comfortable with. What have we been doing first? Tangent ratio. Lie under yourself. The tangent ratio. So I'm going to first write the tangent ratio, and then I'm going to flip it. Okay? So I always pause, and then I'm going to go right first off to the side. I'm going to go first write the tangent. I'm going to go first write the tangent ratio. Okay? So that's my thing. You don't have to do it like I do it, but in my head, I always go write the tangent ratio first. So let's go do that. I'm going to go do the tangent ratio. So go stand at angle D. Okay, so what's the tangent ratio for angle D? Everybody? Opposite of adjacent. Thank you, Jamani. Jamani said 24 because that's the opposite. What's my adjacent? 24 root 3. So I'm going to go with something I know I'm familiar with. The only thing I got to remember with cotangent, it's the reciprocal of tangent. I'm not trying to remember adjacent over opposite. Just, I don't know, it sounds weird. So now I flip it. Once I know this, I flip it. I'm not going to rationalize it or anything because when I flip it, hey, what's the reciprocal of that? Right. Thank you, Mike. When I flip that, do I have to rationalize anymore? No, I took care of it by itself, didn't it? What's the only thing, excuse me, what's the only thing I have to do now? Yep, simplify those 24s, don't I? What happens to the 24s? Yep, they cancel out. And what's my final answer? Just root 3. So the cotangent of angle D is the reciprocal of the tangent ratio. I always go do my tangent ratio, flip it, reduce if I have to, or do anything else. But that's how I would always encourage you to do it. Because you guys know what the tangent ratio is. And then reciprocal. Okay? Let's do another one. Let's go do the cotangent of angle E. Okay? Go do me the cotangent of angle E. They'll stand at angle E. I, again, always like to do the tangent ratio first. You don't, but I like to do that. I'm going to go stand at angle E, and I'm going to go do the tangent ratio. What's the tangent ratio? Opposite flips on me, doesn't it? Adjacent flips on me. So for tangent, that's where I start. When I make my answer key, that's what I'm doing. I get opposite over adjacent, don't I? I know that by heart. I can do that in my sleep. And then I do the cotangent ratio. What's the reciprocal of that? That's it. That's all I need from you. You got to remember it's the reciprocal of the tangent. That's the only new thing for today. And then do whatever you need to do algebraically. Now, what do you got to do here? What's that? I got to rationalize, don't I? Yeah, it sucks. You still have to end up with it sometimes. Now, before I multiply by root 3 over root 3, says Brooklyn, I'm going to get rid of those 24s, reduce the size of those numbers. If I multiply, or sorry, how can I get rid of those 24s? Don't they just cancel out? So actually what I'm working with is just 1 over root 3. Hey, just reduce that thing by 24. Boom. I'm working with a much smaller number set. 1 over root 3. Now I'm going to take Brooklyn's advice and rationalize its denominator. 1 over root 3 rationalized by root 3 over root 3. And clean that sucker up. And what do you got? Root 3 over a perfect square of 9, which I heard is, yep, 3. That last part's nothing new. We've been doing that last part. The only new part today was remembering now the cotangent is the reciprocal of tangent. That's it. That's it. That's it. That's it. All right. I say that's it. We're going to do one more thing. That's not in your book. So it's not in your book. We like to talk about it. It's for a variety of reasons. You're going to see it next year. You're going to see it on the SAT. It's not in your book. So we're going to evaluate with your calculator now. So you got some blank space up here where you got in your book. So we're going to add in an extra example here really quick and have your calculators handy. All right, I want you to evaluate the cotangent. Somebody give me a number. 5 I heard first, and then I'll come back to the other number. All right, cool. Those are all great. There's not a bad number out there. I want you to evaluate the cotangent of 5 degrees. Now, what the hell is that? So, here's the thing. Your calculator, I'm about to bring in my calculator. Your calculator, when you say evaluate, I can plug in, let's say I typed in the cosine of 5 degrees. When you say cosine of 5 degrees, your calculator is going to look in its libraries. It's going to go look at the 5-degree angle, and it's going to go look at the cosine angle, and it's going to go find this number. And it's saying, hey, if you wrote that as a fraction, the adjacent and cosine is what? Adjacent hypotenuse? It's going to go find the adjacent hypotenuse that creates that triangle. Okay? So we can write that as a fraction. It's going to say for 5 degrees, the adjacent and the hypotenuse would create, the adjacent and the hypotenuse would be that ratio. Okay? We now want to say, hey calculator, what is the adjacent, or cotangent, what is the opposite and adjacent sides that create me the cotangent of 5 degrees? The problem is that some of you are searching in your calculators. Where's the cotangent button? Have you found it yet? Appears there's not one.
Wait.
Actually, what? Tell me where it's at, Trent. Is it hiding?
It's somewhere.
It's somewhere. Oh, okay.
Are we talking about this one? How to get the -1 or something?
There's a -1 there. Okay. Yeah, it's not there. Okay. Now, if you had a different type of calculator, it would be there, but it's not there. And by the time you would actually do it, there's a shortcut to this. Your calculator is not doing the cotangent function. But what it can do is, what can it do? It can't do so much. Okay, what is the cotangent the reciprocal of? It's the reciprocal of the tangent. So what your calculator can do is the reciprocal of tangent. So what we're going to tell our calculator to do is, hey calculator, go do 1 over tangent of 5 degrees. So what the calculator is then going to go do is go find that. And as it spits that back out, all right, it is going to spit out that number, okay? But the calculator here cannot do our cotangent ratio for us. So you got to again remember from today, cotangent is the reciprocal of what? Tangent. The way that I always remember it is those T's. COT with TAN. Those T's they get together. When I give you the 2D ones on Wednesday, Thursday, they don't have T's. So that's how you remember it. Okay? So when you type that in, you get an ugly number, don't you? We typically round those to nearest tenths, hundredths, or thousandths. Read the directions, whatever it says. Let's go to nearest hundredth on this one. So what's this nearest hundredth, please? 11.43. Okay, read carefully. 11.43. All right, let's go with one more then. Deacon, you said 27 degrees, right? So let's go calculate the cotangent of 27. You do the same. You got to remember cotangent is the reciprocal of what? 1 over the tangent of 27 degrees. Whoops. And let's round this one to nearest thousandth. Thousandth is how many degrees, or how many decimals? Okay. 1.96. There you go. 1.963 we just said. All right. All right. And that's where we'll pause things.